Hello, welcome to the ICML 2021 workshop on theoretic foundation, criticism, and application trend of explainable AI. This is Balaji Ganesan with my colleague Aniket Saxena. Today, we will be presenting our work towards automated evaluation of explanations in graph neural networks. This is joint work with collaborators from IIT Madras, IBM Research, IBM, and IBM Data and AI. GNN explanations are still quite hard for users to understand. So before we present these explanations to end users in a product, or we give it to human annotators to evaluate them, it might be a good idea to automatically evaluate them to generate some quantitative results. However, methods to automatically evaluate evaluations are still not available in the literature. Imagine law code. It is often said that a case with strong circumstantial evidence is a stronger case than even a case with witness testimony, which is considered direct evidence. This is because the witness testimony might be motivated or the witnesses may not know the complete information. Hence, a case which has circumstantial evidence will prove each of the points in the case. However, even if they are not proving the whole case, they will substantiate parts of the case. Hence, the circumstantial cases are considered stronger than witness testimony based cases. We want to apply this idea to GNN model explanations. We have in fact tried this approach to a limited extent in the work referenced here as one. There we had used path ranking approach as well as information retrieval techniques in order to substantiate link prediction results as shown in the image here. Now, can we do better? So before we understand how we can solve this problem, let's first see some of the missing information in GNN model explanations. Aniket?
So the existing approaches use some perturbation-like methods where we are trying to perturb the features of nodes or even edges just to see which edge or node is more important to explain a particular prediction coming out of from uh, original GNN model. So, in perturbation-based methods, MLP is quite popular, where we are using MLP just to assign different edge weights to each of the edges that, which are present in our original input graph. So, if any edge contains features which are not contributing more to the output, we will assign it to 0 in order to drop or even prune that edge, considering that this edge is not so important for a particular explanation. So why we are using MLPs here is having twofold reasons. First of all, it captures global view of the model. So global view here means we can explain multiple instances at the same time. And second one is MLPs are very good at approximating the derivatives of learned desired function. Here, desired function is nothing but our explanation function we are trying to learn using MLP. So here in these approaches, one thing is missing, that these perturbation-based methods are not utilizing global structure information. So global structure information means means that there are many more edges in the input graph that can influence the prediction for particular node. So we at that moment we need to incorporate the information from different substructures as well in order to understand how they can influence. So for that, there is one recent approach called subgraph explorations, wherein we are trying to identify or even explore different subgraphs in the form of substructures in order to better understand which subgraph of the specific input graph can contribute more to the GNN-based models output. Yeah, and that's it.
All right, with that background, now we will consider two techniques from our experiences in the industry and from the literature that we could use to solve this problem. The first one involves clustering. In a problem known as entity matching, um, we are trying to use clustering as a way to substantiate the explanations. Consider the image in column 2. All the nodes in this particular diagram are marked as belonging to a single real world entity. Now, each of these entities are not pairwise linked to each other, but each one of them is linked to at least one other node where the link indicates that there is entity matching. Now, in order to explain this, we have tried using clustering on the node attributes as well as the relationship attributes, and we came up with a lot of clusters which are somewhat depicted in the dotted circles here. Now, if we can show why these clusters all belong to a single entity, meaning if we can explain the dotted lines between the subclusters, we might be able to explain why all these nodes have been marked as belonging to a real world entity. So this is what we call as trying to explain GNN model predictions using clustering. And this is still work in progress. Now, another approach which could be used comes from neurosymbolic reasoning. So imagine like a well-known assertion or an example from symbolic reasoning. If we have all men are mortal as the universal truth, then we have Socrates is a man as an assertion. This could either come from the training data or it could be another prediction. If we have these two information and then the GNN model predicts Socrates is mortal, then we can derive the same conclusion using modus ponens based on the two other assertions. So now we have the GNN model prediction and we have the same result from the symbolic reasoning using modus ponens. Now this can be the symbolic explanation which could then substantiate any explanation we might produce using the other methods that Aniket spoke before. So we have the GNN model prediction, one explanation from the subgraph and other approaches, and one symbolic reasoning based approach. We believe these two combination kind of adds more value for the end user than the GNN model explanation alone. Of course, the output from the symbolic reasoner can also be converted into a natural language explanation. For example, this could simply say all men are mortal, Socrates is a man, and hence Socrates should also be mortal. So that we can produce that kind of natural language explanation. And further, using the approach that we had used in the reference paper 3, we could also look whether such sentences occur in the corpus. Maybe the knowledge graph or the graph is built from, say, Wikipedia or from any corpus. And if we have a sentence like the one that I just gave, then we can search whether such sentences are available in the corpus, and that would further substantiate the explanation. So these are some of the ideas that we have. We will conclude here and hope you have a great workshop and the conference ahead. Thank you.